In this video, we're going to talk about enantiomers. So, an enantiomer would be a structure that looks like a mirror image of itself. Let's go through one example. If we were to draw the enantiomer of this Fisher projection, we would simply draw the same compound on the left side. However, imagine the red barrier here as being a mirror. So the left and right sides would be shifted, but then the bottom and the top stay the same. So these two compounds would be enantiomers of one another. If we were to draw a more complicated Fisher projection, how do we draw the enantiomer for this compound? So you're going to flip the groups on the right side and put them on the left side. So on the left, we're going to have a hydrogen and a chlorine, and on the right side, we're going to have a bromine and a methyl. And we're still going to keep the amine on the bottom and the alcohol on top. Now, if I were to draw this haloalkane with, let's say, a fluorine on top, how would you draw the enantiomer for this compound? One trick you can use is if you have one chiral center like this, you can simply just flip the chiral center from a dash to a wedge or a wedge to a dash, and you would have an enantiomer. Now, if you have two chiral centers, that wouldn't be a chiral center. Put an OH here. If you were to have two chiral centers like this, what you would do is you draw the same structure, but this time you would actually flip both of the chiral centers from being a dash to a wedge or the other way around. Let's go over an example where this would happen in a ring. So let's say we have a 6-membered ring, and we have an iodine coming out of the page, and we have another iodine going into the page. How do we draw the enantiomer for this compound? There are two ways you can do it. One way would be to flip the groups around to the other side. So move them from right to left and keep the configurations around the chiral carbons the same. So that's one way. The other way would be to change the configuration around the chiral carbons and keep them on the same side. So on the bottom, I'm going to keep the iodines on the right side of the ring, but I'm just going to change the configuration of the chiral carbons. So there's two ways you could draw it. Now let's go over how these would affect R and S configurations. How do we draw the enantiomer for this compound? First thing you want to do on the right side is draw the carbon, and As you can see, we have on the left side a methyl coming out of the page. So you would switch that to the right side, and you can see you have a chlorine just straight. We have a bromine going up, so you'd keep down the same up direction, and we have a hydrogen going into the page on the bottom. Now these two structures are going to be enantiomers of one another. And when you have enantiomers, they're going to have different configurations. So we're going to prioritize these based on numbers. So bromine is going to be number 1 because it has the highest atomic number. Second group is going to be chlorine, and then we're going to have the methyl as number 3. Hydrogen is number 4 because it's the smallest in terms of just atomic size, and it's also going into the page, which is how we want it normally. So we're going to start at 1, and we're going to count like this. As you can see, we are going clockwise, which would mean that we have an R configuration. On the enantiomer on the right side, we have bromine 1, chlorine 2, methyl 3. If you want to go 1, 2, 3, you're going to go counterclockwise, which would be the S configuration. So enantiomers have different configurations. They have the opposite configurations. Now let's go over one more example. And this is a example you want to be careful with because it's easy to make a mistake like this when doing practice problems or just on a test. If you have the same structure looking similar to the last one, but you want to draw the enantiomer for it, go ahead and try that. You can see that it's not too hard. However, let's try and find the R and S configurations for these two compounds. On the left, our bromine is the first group, then we have chlorine, then we have the methyl, and the carbon, or the hydrogen, is number 4. Now, if I were to go from 1, 2 to 3, I would be going in a counterclockwise direction. So you'd think that this is S. However, since the hydrogen is coming out of the page, it's actually going to be the opposite. So even though it looks like an S, it's actually going to be an R. So this is an R configuration because the hydrogen is coming out of the page. The hydrogen is number 4. It's coming out of the page as opposed to going into the page. So therefore, this is going to be an R configuration. On the right side, if you go in this way, it looks like this is an R because it's going clockwise. However, the hydrogen is coming out of the page once again, so this is actually an S. So as you can see again, the configurations around that central carbon are different.